Once upon a time in the heart of Europe, where the towering Alps whispered tales of ancient civilizations, a modern-day saga unfolded, a tale of France and Italy, their histories intertwined like the mountain paths they sought to conquer. In the shadow of the Alps, France and Italy shared a dance through time. From the echoes of Roman footsteps to the Renaissance whispers, these lands bore witness to centuries of shared cultural symphonies. As empires rose and fell, the roots of collaboration ran deep, setting the stage for a contemporary alliance. Welcome, fellow explorers, to the ancient tapestry of the Alps, where every rock tells a story of the Earth's tumultuous journey through time. In today's episode, we unravel the geological odyssey that shaped the landscapes between Italy and France, featuring the captivating tale of the Mont Cenis region. Millions of years ago, when the Earth was a canvas of raw potential, a colossal ballet began. The Eurasian and African tectonic giants pivoted towards each other, and the Alps were born. This majestic mountain range, spanning from France to Italy, emerged from the embrace of these ancient behemoths. Picture a time, around 30 to 40 million years ago, when seismic forces beneath the Earth's surface thrust mighty peaks into existence. The Alps, with their snow-capped summits, were sculpted by the relentless push and pull of tectonic plates. In this grand overture, the landscape we now know as the Mont Cenis area took its form. As our geological drama unfolded, a once unified landmass began to fissure. The area between Italy and France, once connected, faced a separation spurred by the ceaseless dance of tectonic forces. Eons of upheaval and pressure mold the landscape into the distinct regions we recognize today. The Alps, with their towering majesty, have long served as both a barrier and a bridge between France and Italy. The Mont Cenis Pass, a historic crossing point, witnessed the footprints of traders, soldiers, and pilgrims navigating its rocky trails. This was a stage where cultures collided, and alliances were forged amid the dramatic backdrop of snow-capped summits. And to connect Italy to France due to mountains formed due to tectonic activity, they needed a solution, and they created the Frejus Rail Tunnel, Mont Cenis Tunnel. The Frejus Rail Tunnel, also known as the Mont Cenis Tunnel, is a rail tunnel spanning 13.7 kilometers, 8.5 mi, in the European Alps. It connects the Turin-Modane Railway through Mont Cenis, linking Bardonecchia in Italy to Modane in France. The tunnel passes beneath Pont du Frejus, 2,932 meters, and Col du Frejus, 2,542 meters. Construction, led by civil engineer Germain Sommeiller, began in August 185. Despite initial skepticism, the tunnel was completed in 13 years, opening on 17 September 1871, marking a new era of interaction between France and Italy. The Frejus Tunnel remains a crucial link in the connection between Rome and Paris, via Turin and Chambéry. It underwent modernization in the 2000s to accommodate wider rail vehicles. The Mont-d'Ambin-Base Tunnel, part of the Turin-Lyon high-speed railway project, is planned to enhance transit capacity between France and Italy. The original portal on the French side at Modane, used for a decade, was bypassed in 1881. The tunnel was redirected to a more stable entrance to the east, leaving the original as a monument. Modernization efforts included enlarging the bore for wider rail vehicles and various enhancements, focusing on civil works and electrical systems. Defensive fortifications were constructed near Modane, as the Frejus tunnel became a potential invasion route. Fortifications such as Fort du Repleton and Fort du Sepi were built in the late 19th century, along with additional constructions during the 1930s. A blockhouse along the rail line has become a tourist attraction, known as the Leaning House, built in 1939 and tilted during German retreat in 1944. However, due to some reasons, the Lyon-Turin International Railway line, including the Mont-Cenis-Base Tunnel, is a major infrastructure project aimed at improving transportation connectivity between France and Italy. While the existing Frejus rail tunnel already connects the two countries, there are several reasons for the necessity of the high-speed Lyon-Turin line and the construction of the Mont-Cenis tunnel. 1. Capacity and congestion. The existing Frejus rail tunnel has limitations in terms of capacity and is often congested, especially with the increasing volume of freight and passenger traffic. A new high-speed line can help alleviate this congestion and provide additional capacity for transportation. 2. Speed and efficiency. High-speed rail lines generally allow for faster travel times, making the overall transportation network more efficient. The Lyon-Turin line is designed for high-speed trains, which can significantly reduce travel times between Lyon and Turin compared to conventional rail lines. 3. Freight transport. The Lyon-Turin line is not only for passenger transport but also aims to enhance freight transport. The Mont-Cenis-Base Tunnel, which is part of this project, is specifically designed for freight trains. This can improve the efficiency and competitiveness of freight transportation between France and Italy. 4. Environmental benefits. High-speed rail is often more environmentally friendly compared to other modes of transportation, especially when compared to road and air travel. By promoting rail transport, the Lyon-Turin project contributes to reducing greenhouse gas emissions and mitigating the environmental impact of transportation. 5. Improved connectivity. The Lyon-Turin line enhances connectivity between major European cities, contributing to a more integrated and efficient European transportation network. It facilitates smoother connections between different modes of transportation and promotes economic and cultural exchanges. 6. Modern infrastructure. The Lyon-Turin project involves the construction of modern and state-of-the-art railway infrastructure, including tunnels and tracks. This can lead to improved safety, reliability, and overall performance of the rail network. 7. Strategic importance. The Lyon-Turin connection is part of the Trans-European Transport Network (TEN-T), a network of priority transport infrastructure projects identified by the European Union. It plays a strategic role in enhancing European mobility and economic competitiveness. In summary, the Lyon-Turin International Railway Line and the Mont Cenis Tunnel address the limitations of existing infrastructure, aim to improve transportation efficiency, promote sustainable modes of travel, and contribute to the overall development of a well-connected and modern European transportation network. So, Europe decided to build a 27 billion project called the Turin-Lyon High-Speed Railway, an international rail line under construction between Turin and Lyon, with a length of 270 kilometers. The Turin-Lyon High-Speed Railway is an international rail line under construction between Turin and Lyon, with a length of 270 kilometers. The international section includes the Mont d'Ambin Base Tunnel, the world's longest rail tunnel at 57.5 kilometers. Projected cost, €25 billion. With €8 billion allocated to the international section. Objectives: 1. Transfer freight from trucks to rail to reduce CO2 emissions and local air pollution. 2. Provide faster passenger transport to decrease air traffic. Design speed, 220 km/h. Not classified as high speed by European Commission standards. EU funds 40% of tunnel costs, potentially increasing to 55%. Criticized for high cost and declining traffic. Environmental risks during tunnel construction. Air travel may remain faster on the Milan-Paris route. Opposition from the No TAV movement. Civil engineering started in 2002. Expected base tunnel completion in 2032. 2012 French Court of Audit questioned cost estimates and traffic forecasts. Turin-Modane Railway since 1872. Challenges include sharp curves, steep gradients, and low tunnel ceilings. Capacity limitations and low usage due to restrictive conditions. Maximum gradient, 12.5 per thousand, compared to 30 per thousand on the old line. Maximum altitude, 580 m, compared to 1,338 m on the old line. Allows heavy freight trains at 100 km/h and passenger trains at 220 km/h. Line sections. 1. French section. SNCF Réseau manages between Saint-Jean-de-Maurienne and Lyon. Separate paths for passengers and freight. 2. Italian section. RFI manages between Bassolino, Susa Valley, and Turin. 3. International section. TLT SAS manages the Mont d'Ambin Base Tunnel. Construction progress, as of 2023. Civil engineering started in 2002, with the base tunnel's expected completion in 2032. Disagreements in the Italian government delayed tunnel construction tenders. Contracts signed in 2020 and 2021 for tunnel construction, with ongoing progress. Opposition from residents in 112 towns and villages. and the No TAV movement in Italy has been opposing the construction since the 1990s. Arguments against the project include concerns about the cost, safety, environmental impact, and potential health risks. The Mont Cenis base tunnel, part of the Lyon-Turin rail project, stands as an engineering marvel connecting France and Italy through the Alps. This modern endeavor blends cutting-edge technology with the timeless grandeur of the natural world. Embark on a journey through time and solid rock as engineers carve a path beneath the majestic Alps. The tunnel's construction reads like a geological epic, revealing the Alpine saga from its rocky birth to the present day. The Mont Cenis base tunnel is a railway tunnel under construction, one of the longest in the world, connecting France and Italy. Construction began in 2019, aiming to enhance transportation efficiency, especially for freight, by providing a direct route through the Alps. It involves cutting-edge methodologies, including tunnel boring machines, to navigate the challenging mountainous terrain. Meticulous environmental considerations are integrated into the construction process. The transformative impact on European transportation, providing efficient rail connectivity for goods and passengers, is a key objective. The tunnel is designed to accommodate high-speed and heavy freight trains, promoting a modal shift from road to rail. Joint efforts between France and Italy exemplify international cooperation. Tunnel Euralpin Lyon-Turin, TELT, oversees the construction and operation. The project aims to reduce the environmental impact of freight transportation and stimulate economic development. It aligns with European efforts for sustainable transportation and integrated connectivity. Construction began in 2019, with an expected operational date in the coming years. Competitive tenders and agreements between France, Italy, and the European Union illustrate international commitment. Contracts for the Mont Cenis base tunnel were awarded in July 2021 for different segments. Reconnaissance work started in 2002, and formal agreements were reached in 2016. Opposition, mainly organized under the No TAV movement, influenced changes in the tunnel's alignment. Upon completion, it will be the longest rail tunnel globally, surpassing the Gotthard base tunnel. The tunnel spans 57.5 kilometers, presenting significant engineering challenges. Tunnel portals are in Saint-Jean-de-Maurienne, French side, and Susa, Italian side. Geothermal profiles and geological challenges shape construction methods. The estimated cost is €8 billion, shared by the French and Italian governments and the European Union. EU funding commitment of 40%, potentially increasing to 55%, comes with conditions on French accesses. The tunnel will serve both freight and high-speed passenger trains, promoting a modal shift from road to rail. It aims to reduce CO2 emissions and enhance the resilience of the European transport system. This paper provides a comprehensive overview of the Mont Cenis base tunnel, detailing geological, hydrogeological, and geomechanical aspects. The new Lyon-Turin line, NLTL, is a significant railway infrastructure connecting Settimo Torines in Italy to Lyon in France, crossing the Alps. The project encompasses a 57.5 kilometers base tunnel, crucial for transforming the route from a mountainous to a flat rail route. The base tunnel is designed for a nominal speed of 250 kilometers per hour, operating at 220 kilometers per hour, with a maximum longitudinal slope of 12.5 per thousand. The tunnel consists of 2 parallel tubes connected by 3 bypasses per kilometer, equipped with inclined axis adits, railway service areas, and ventilation shafts. The tunnel traverses various geological complexes, including loose granular soils, complex rock mass formations, and high-strength or abrasive rock masses. A geological and geomechanical model was developed to assess excavation methods, risks, and mitigation measures. Hydrological investigations were conducted to understand aquifer interference, water ingress, and impacts on water resources. Specific measures were implemented to interface with groundwater systems, including using a slurry shield TBM and waterproofing measures. The cross-border section of the Lyon-Turin base tunnel is under construction, with 12% of tunnels excavated and 20% under contract. Key axis adits and ventilation shafts have been completed, contributing to the progress. The La Maddalena Exploratory Tunnel, spanning 7 kilometers, served to investigate the Ambin Massif, refine design documents, and enhance data reliability. Detailed investigations were conducted at the Saint-Martin-la-Porte site, contributing to a novel design concept for challenging conditions. The ratification process of the 2015 agreement sets the stage for main tenders. Public tenders are underway for construction management, and significant works are planned for the coming years. The NLTL project prioritizes environmental sustainability, focusing on the circular economy, landscape enhancement, and cultural integration. Reuse of materials, landscape design, and community integration are integral aspects of the project. An anti-corruption protocol has been in place since 2012, making the Lyon-Turin the first case in Europe of transnational anti-mafia legislation. Strict regulations and audits ensure compliance throughout the construction process. Timeline and updates. As of the last update in January 2022, the Mont Cenis base tunnel is progressing according to its construction timeline, with the completion date anticipated in the coming years. Regular updates from Tunnel Européen Lyon-Turin, TELT, and relevant national railway companies are recommended to stay informed about the latest developments, milestones, and any adjustments to the project timeline. The new Lyon-Turin line, NLTL, an essential component of the Mediterranean Corridor, one of the 9 TEN-T network's corridors. The future European Metropolitan Railway aims to promote the movement of people and goods using an ecological mode of transport, the train. The goal is to reduce road transport, which increases pollution and greenhouse gas emissions. The core element of the new line is the 57.5 kilometers Mont Cenis base tunnel. Geological model. The reference geological model is based on data obtained during the excavation of the inclined axis adits at Saint-Martin-la-Porte, La Praz, and Modane, including the La Maddalena exploratory tunnel. With the planned investigations completed, all collected data will allow technical and economical optimization of the construction phase and operation and maintenance of the line. Environmental impact. The impact on water resources is minimized by using a full-round waterproofing system up to a hydrostatic pressure of 10 bar. Expected residual water flows at the portals are exploited for both drinking water and heating purposes. Progress and workforce. With 12% of the tunnels already excavated, there are currently 800 people working on the NLTL. This unique project, with its extraordinary history and innovative features, has been proposed as the subject of an international case study. Project completion expected date, 2032. Thank you for watching this video and stay tuned.